Welcome back, folks. You usually hear about numerous types of electric vehicles. There are hybrid electric vehicles, plug-in hybrid electric vehicles, battery electric vehicles, and several others. In this section, we will look into these types of EVs and you will learn more about how to classify an electric vehicle type. So the vehicles can be categorized based on drivetrain and fuel type, such as the conventional internal combustion engine vehicles and the alternative fuel internal combustion engine vehicles and the electric vehicles. The internal combustion engine is generally referred to by its short form of ICE. The conventional ICE vehicle includes the petrol and diesel vehicles. The alternative fuel ICE vehicle refers to the vehicle that run on a fuel other than the petrol or diesel, like autogas, natural gas, biofuels, biodiesel, or hydrogen. In all types of ICE vehicles, the drivetrain used is mechanical. In comparison, the electric vehicles use an electric drivetrain for their momentum. In this lecture, we will emphasize on the electric vehicles. While battery electric vehicles have an electric drivetrain, they can be categorized dependent on their fuel sources, their propulsion system, and how their propulsion system are hybridized. All in all, we have hybrid electric vehicles, abbreviated as HEVs, plug-in hybrid electric vehicles, abbreviated as PHEVs, battery electric vehicles, abbreviated as BEVs, and fuel cell electric vehicles, commonly known as FCEVs, and later on sun-based or solar electric vehicles. The hybrid electric vehicles, the HEVs, sources its fuel exclusively from petrol or diesel, while it utilizes both the electric engine in mix with the battery and an ignition motor for drive. The plug-in hybrid electric vehicles, the PHEVs, is like the half-breed electric vehicles that is utilizing both an engine and an electric engine like a motor for drive. The thing that matters is that the battery of the PHEVs can be charged by power through a charging port. Interestingly, the battery electric vehicles doesn't have an engine and it's absolutely controlled by the power rather than petroleum products. Further, the propulsion is exclusively determined by an electric engine, that is motor. At long last, on account of the hydrogen-based and sunlight-based electric vehicles, the energy is straightforwardly sourced from the hydrogen utilizing a power device or from sun-oriented boards or the solar panels separately. While the propulsion is finished utilizing an electric engine or the motors, presently, how about we take a look at these vehicles individually? For reference, allow us to begin with the fuel and the diesel vehicles that utilizes an IC engine for propulsion. A petrol vehicle commonly utilizes a spark ignition engine as opposed to the compression ignition frameworks or the engine utilized in diesel vehicles. The IC engine uses a complex mechanical transmission framework to move the torque to the wheels. Like a petrol vehicle, the hybrid electric vehicles are also fueled by an internal combustion engine, but also an electric engine or the motors can impel the vehicle by utilizing the energy put away in the batteries. The batteries is thus charged by drawing energy from the IC engine by utilizing the electric engine or the motor as an electric generator. To move the electric engine and the generator mode, a smart power electronic engine drive is utilized. The additional torque given by the electric engine or the motor takes into consideration a more modest IC engine. Further, the electric engine or the motor permits the IC engine to be worked in its ideal productivity point, bringing about better mileage. What we have quite recently observed is a parallel hybrid design where both the motor and the engine can control the wheels simultaneously. A series hybrid electric vehicle then again works in an unexpected way. The IC engine is utilized to drive a generator and give electrical torque to the electrical engine and to charge the battery. This is a typical impulsive technique which has been utilized in trains for a long time. The electric engine is the main torque supply unit with an immediate association with the wheels. The favorable position is that the IC engine can be worked at its most productive highlight, create the vital current for driving the electric engine or the motor or charging the battery. The third sort of hybrid is the arrangement series and parallel mode, half and half. This has the adaptability to work in one or the other series or parallel mode by utilizing a power split. It has a generator to charge the battery as found in the series hybrid electric vehicle. Also, it has an IC engine and electric engine, that is the motor, together fueling the wheels as found in the parallel hybrid electric vehicles. Despite the fact that this kind of design is more adaptable as far as driving modes is concerned, it is additionally more unpredictable and obviously exorbitant. The Toyota Pyrus is the case of a hybrid electric vehicle based on the series parallel style. The plug-in hybrid electric vehicles are like hybrid electric vehicles in that they have both electric and IC engine constantly for propulsion. The fundamental distinction lies in the way that PHEVs, the batteries are bigger and can be remotely charged utilizing the onboard charger. This is close to the way that the battery can be charged utilizing the IC engine while driving. This empowers the PHEVs to utilize the electric engine or the motor during bigger time frames when driving. That implies for bigger distances. This implies that the PHEVs can drive electric for most city drives and change to petroleum derivatives for long rides, eliminating any range uneasiness. What is appeared here is a PHEV dependent on a parallel drivetrain engineering. Like what was seen previously, a PHEVs can be constructed dependent on series and series parallel structures too. The Mitsubishi Outlander is a case of a plug-in hybrid electric vehicle based on the series parallel style. The inconvenience of the HEVs and PHEVs is that they keep on utilizing the petroleum derivatives and consequently have tailpipe discharges. To defeat these, the battery electric vehicles or the all electric vehicles EVs just have an electric engine or the motor and no IC engine. The vehicle utilizes an enormous battery bank to control the electric engine or the motor, and the battery should be charged from an electric plug when it is left. The Tata Nexon EV is a case of a battery electric vehicle. Next, we take a view at a hydrogen-based EVs. A fuel cell electric vehicle substitutes the huge battery of a battery electric vehicle for a fuel cell stack to create power from the hydrogen fuel. In contrast to a battery, an energy unit isn't a capacity device, yet a device that produces direct current from a chemical responses. A little battery is as yet utilized as an energy cushion and to control the electric engine utilizing the engine or the motor drive. A fuel cell electric vehicle has the benefit of short refueling times and broad-ended driving reach when contrasted with battery electric vehicles. Here is the case of a fuel cell electric vehicle, the Toyota Mirai. Since we realize all the EV types allow us to think about them dependent on the factor called hybridization rate. The hybridization rate is a measure used to depict how firmly the powertrain is hybridized. This level is controlled by the job that the electric engine or the motor has in the performance of the vehicle. It is characterized as the proportion of electric power to total power and is dissipated by this condition where PEM is the power given by the electric machine and PICE is the power given by the IC engine. The grouping for various estimates of the hybridization rate is appeared in the bar diagram, including the ordinary estimations of the power rating of the electric engine. On the two sides of the bar, we can see that the ICE vehicles hybridization rate is 0 and the battery EV's hybridization rate is 1. At the point when the hybridization rate esteem is more modest than 0.24, this HEV is viewed as a miniature hybrid. At the point when the hybridization rate is between 0.24 to 0.38, it is then recognized as a semi or gentle hybrid. At the point when the hybridization rate is higher than 0.38, we would then be able to think about it as a complete hybrid. Aside from that, as we presented previously, if the battery of an HEV can be charged from a charging point, it is named as PHEVs. Along these lines, to wrap up, this table shows the diagram of a wide range of electric vehicles. If there should be an occurrence of ICE vehicles, they are exclusively controlled by an IC engine and has the most discharges. The hybrid electric vehicles and the plug-in hybrid electric vehicles are controlled by both an IC engine and the electric engine or the motor that utilizes energy put away in a battery. The battery is charged by the IC engine for both. For a PHEV, the vehicle can be connected to an electric power source of a charge to charge the battery. Electric or the battery electric vehicle utilizes no non-renewable energy sources and have zero tailpipe outflows. Like a PHEVs, the EV batteries are charged by connecting the vehicle to an electric power source. At long last, FSEVs utilizes the fuel cell controlled by hydrogen and battery to control vehicle utilizing an electric drivetrain. Thank you for this lecture.